Hi guys, you're welcome to my channel. All right, now today we're going to discuss about water level control, part three of the water level control. We have done part one, part two. This is part three. Then, just to remind you that this my page is strictly for automation. It's for automation career. So all this program and logic I'm trying to bring is to prepare you for automation career. We are going to automation must understand design and logic and control system. So I'm trying to give you a solid foundation, trying to give you a solid foundation for your automation career. So I'm bringing up different type of design. Like now, this one is for water control. We have done part one, part two. This is part three. If you have not gotten that part two and part one and two, I think I have the view here. Yes, this is part two. Just conventional method of using sumo pump to pump water to your tank and you control it automatically using flow switch. Then part one is the conventional method of controlling your water system from your tank to something like this. We converted this to schematic diagram and they incorporate a flow switch for the second part. Okay. All right. So this is another logic. Okay. Now, if you want to also have a solid foundation for automation, you should be endeavor to subscribe to my channel and follow my YouTube channel. Okay. Or you contact me via this number, then I can also take you on more detail of the design. Okay. All right. So let's proceed now. This particular logic is for water level control. All right. So now this is my tank. Supposing you want to control your water automatically, maybe you set up a water factory, you're producing bottled water, and you have a reservoir, then you want water to be controlled from the reservoir and monitor the water so that you will not run short of water. So this is one of the applications that will enable you to do that. All right, but these are just basic way of controlling liquid or water. We have more advanced method as we progress. We are going to be advancing on water or liquid control in a more complex manner. Okay. All right. So let me walk you through the schematic. Then we are also going to convert this schematic to ladder diagram and also write a program to PLC and allow PLC to take over the control. All right. But like I always advise that before we write a code on PLC, we must have to design a system, set up a system we want to control using PLC. All right. Okay. Sorry. So let's start. So this particular logic, this area here is my retainer logic. It's my lashing logic. First of all, initiate command on this logic before this other second logic we start the operation. Here is the initiation for you to initiate the command to commence. Then here is the logic that will be responsible to control the operation of the water. Then this is the tank. All right. Now, this is my switch. Limit the water sensor. I'm using water sensor here, not flow switch. Let me show you flow switch. In our previous design, we use flow. Look at flow switch. We use flow switch to control this water level in this tank. Okay, that was the level 2. So this level 3 is more advanced. So here we are using sensor, water sensor. Okay, now operation sequence is what I'm going to describe. Let me put up a narrative. Supposing you want to produce, you have a water process that you're producing bottled water and you have a reserve tank. I don't want the operation to run short of water and you have a reserve tank to control. So you have to automate the tank, the water or the liquid coming to this place. You want to control the threshold, the minimum level, and the maximum level. Okay, so this is what you do. You install this particular device, this water sensor, at the set maximum set level. and they also install this at your limit, your minimum set level. This is the desktop and this is the maximum set point. All right, so you install them respectively. Then this is the discharge pump and this is the inlet pump. The water pump to the tank through this inlet. Water drain from the tank through this outlet. Both of them has output. They are two different pump. We have a pump here. We have a motor responsible to pump water into this. Then we have another motor here to get activated for the water to discharge. So both of them, look at them here, drain pump and this is filling pump. So this filling pump is going to take water through this place. Then this drilling pump is going to discharge water through this place. All right. Okay, now let me also introduce the logic. Okay, the ideal method of you to understand this process is for you to register the course. Okay, unless you are already into the system, you can also digest it this way. All right, let me walk you through. Now I have to initiate the command through here and the operation commence from here. Now this is my low level switch, which is this one, which is this uh, low level switch is going to be this one. Okay, all right, that is B2. And this is high level switch. This high level switch is this one, B1. Okay, so when you start filling the water here and the water get to this level, this one will get activated, but the water keep coming. Water keep pumping. When you get to this maximum set point, it will trip off. It will shut down this valve, not to pump in. It will now activate this one to drain out. This one will start drilling. When this one drain passes here, this one will get activated, but water still keep pumping. When it come to this maximum level, it will shut down. This one will shut down and they activate this one back to refill again. You will keep recycling until you shut down the operation. Okay, all right. You appreciate this more whenever I want to write want to write PSC program. You appreciate it more. Okay, then I will use a kind of SCADA system to bring in the simulation. You see the simulation. You're going to see the water filling in and drilling. You will see this water. I will change this particular tank. I will change it to something more. I will change it to tank. The real tank, you change it to tank and you see the valve. You see how water levels grow and how water level drain. The movement of the water inside the tank will be going. Okay, so you appreciate it more. We'll come to level 3 and level 4 rather. All right, so let's simulate this. Okay, I initiate the command. I initiate this command here. Okay, this filling water is on. This one is filling. Water is filling to the tank. The filling pump is filling now. Then when the water fill and come to this level, this one will get activated. And this one is this. Once it's activated, look at it here. Then water keep filling because this one is still on. Water keep filling until you get to this maximum set point and it will be activated. Look at it. I represent these two. I represent these two here. So I want to operate them here for you to understand that this one is responding. So let me operate it now. When I operate now, then this one now open, this one open. Look at this filling pump shut down and this drain pump will start drilling. So when it's drilling now, water keep coming down here from here. When you get to this sensor will get activated. So let me activate this now. This is B2, B1. So look at it. Let me activate this. It still keep pumping. Okay, sorry, keep drilling. We're draining, coming down, coming down. When you get to this, let me operate this again. I operate this. It will now shut down and start filling. I will activate filling. Look at filling. So water keep coming in again. So that cycle will repeat, keep going until you shut down the operation. All right. All right, so this is the logic using schematic diagram to design this particular sequence of operation. Now, the next part, I'm going to give you a graphic of the tank. Okay, the next part now, I'm going to give you a graphic of the tank, this tank, so that you see the water coming into the tank and you see water leaving out of the tank. Okay, all right, thank you.